As far as we know, there's only one world in the entire universe that is definitely alive, Earth. We searched Mars. We stared into the poison skies of Venus. We listened to the frozen silence beneath Europa's ice. We studied Titan's orange haze. And still, the biggest question remains unanswered. Are we alone? But then NASA launched a telescope with one mission so ambitious it sounded almost impossible: to stare at a tiny patch of the Milky Way and hunt for hidden worlds one by one. Not giant gas monsters, not blazing stars, but worlds, places, possible second Earths. And what it found did not just change astronomy. It changed the emotional scale of the universe itself. Because suddenly, Earth stopped looking like the only possibility and started looking like one example among billions. In 2009, NASA launched Kepler with a goal that was brutally simple in concept and unbelievably difficult in practice: find planets around other stars, especially the kinds of planets that might resemble Earth closely enough for life to exist. It did this by watching the brightness of stars with absurd precision. If a planet crossed in front of its star, even for a moment, the star would dim very slightly. That tiny dip in light was the clue. Catch enough of those dips, repeat them, and you could prove a world was there. That method sounds straightforward until you realize how small the changes really are. If Earth passed in front of the sun from far away, the sun's brightness would drop by only a microscopic amount, almost nothing. And yet Kepler was sensitive enough to catch changes like that across hundreds of thousands of stars. It watched more than 530,000 stars over the course of its mission and confirmed 2,662 exoplanets. That alone was extraordinary. But the real shock was not the number. It was the variety. Kepler revealed that the galaxy is full of bizarre worlds. Hot Jupiters roasting close to their stars, super-Earths larger than our planet, but smaller than Neptune, lava worlds with surface temperatures hot enough to melt metal, and planets orbiting two stars at once. It was as if the universe had been hiding a catalog of madness in plain sight. But buried among those strange discoveries was something even more important: a growing list of planets that were not just weird, but plausible. Worlds sitting in the right zone, under the right light, with the right hints to make scientists ask the most dangerous question of all: could life be there? The most exciting planets are not always the biggest or the strangest. They are the ones orbiting in what scientists call the habitable zone, the delicate region around a star where a planet could, in principle, keep liquid water on its surface. Not too hot, not too cold. The famous Goldilocks zone. And Kepler did something that changed everything. It started finding Earth-sized or near-Earth-sized worlds in exactly those kinds of places. One of the most talked about examples became K2-18b, a world orbiting a red dwarf star about 124 light-years away. It is much bigger than Earth, more like a mini-Neptune or sub-Neptune, but it sits in the habitable zone and has shown signs of water in its atmosphere. That discovery exploded across astronomy because it was the first time scientists had found water signatures in the atmosphere of a habitable zone planet discovered by Kepler. Suddenly, this was no longer about theoretical second Earths in the abstract. This was about a real distant world with real atmospheric clues. Then there was Kepler 186f, discovered in 2014, which immediately became one of the most fascinating Earth-sized candidates ever found. Its size is close to Earth's, and it sits in the habitable zone of its star. Later studies even suggested that its axial tilt may be stable enough to allow long-term seasons and climate stability, something that matters enormously if you care about habitability, because being in the habitable zone is only part of the story. A world can sit in the right place and still be completely hostile, but if the orbit, tilt, atmosphere, and temperature all work together, then the dream stops sounding naive and starts sounding scientific. Among the most compelling discoveries was Kepler 1649c, a planet found hiding in older Kepler data and recognized later during a reanalysis. What made it so exciting was how eerily close it seemed to Earth in the numbers that matter most. It is only about 6% larger than Earth and receives around 75% of the starlight Earth gets from the sun. That means its surface temperature, if it has the right atmosphere, could be astonishingly Earth-like. Not identical, but close enough to set imaginations on fire. Then there was TRAPPIST-1, one of the most mesmerizing systems ever discovered. even though it lies beyond Kepler's original emotional spotlight. 7 Earth-sized planets orbit a small red dwarf, with 3 of them in the habitable zone. That alone sounds like science fiction, but what made it even more thrilling is how close the planets are to each other. If you stood on one, the others would appear enormous in the sky, entire neighboring worlds hanging above you like giant moons. And because this system is older than Earth, some of those planets may have had billions of extra years for life to emerge and evolve if conditions were right. And of course, there was Kepler 452b, the one many people hyped as Earth 2.0. It orbits a sun-like star and takes roughly 384 days to complete 1 year, strikingly close to Earth's cycle. It is larger and heavier than Earth, which means gravity there would feel harsher, but it is close enough in character to ignite one of the strongest waves of public imagination in modern exoplanet science. The dream of another Earth stopped being a vague hope and started attaching itself to actual names, actual distances, and actual candidate worlds. As thrilling as these individual planets are, Kepler's deepest legacy may be something even more powerful than any single world. It changed the numbers. Before Kepler, Earth-like planets were mostly speculation. After Kepler, astronomers began to understand that they may be common. Its statistical analyses suggested that roughly 1 in 5 sun-like stars could host an Earth-sized planet in a temperature range compatible with habitability. Think about what that means. In the Milky Way alone, that could translate into billions of potentially habitable worlds.